So what we're going to do today is the last section, 7.5, the last section of quadratic modeling. So we started quadratic modeling with me giving you an equation, asking you questions about it. Then we moved into me giving you data points, you giving me the equation, and me still asking you questions about it. Then we moved into a very specific formula, which was what? Projectile motion. And then we did what? What was the next one we did? Well, no, in the quadratic modeling. I just walked around and looked at it. It was called what? Borders. So problems that dealt with borders or frames or mats, things like that. Now we're going to deal with a problem that deals with something called fencing. So it's what you think it is. It's putting a fence around something. So we'll have a few word problems here, and they're going to set up to give you a quadratic equation. So a little bit different than what we've done with borders. And let's just take a look at it. So one of the big differences from this is that in the borders we dealt with area exclusively. Here we're going to deal with, when I'm dealing with fences, I'm dealing with perimeter, like how much fence you have to go around a piece of property. Okay, so let's just dig in with a problem here. Mr. Sherwood is going to fence part of his yard using the back of his house as one side of the fenced-in area. If he has 500 feet of fencing to use, what dimensions would create the largest possible enclosed area? Any ideas? We usually have to start these off with defining what? Somewhat. Starts with a V, a variable, okay? If I look at this, it looks like there are two variables here. When I'm building this rectangular fence, what are my two variables? Well, the two variables are the length and the width. I'm trying to maximize the area. But if I've got a rectangular fence, I know that whatever this length is here, this width will be the same as this width, and then I only have one length here, since I only have three sides. Okay, so let's just say, for example, if this is X, what is this over here? Okay, and this is something over here I don't know, I'm just going to call it Y. Okay, so I've got X is the width, and Y is the length here. Now, what do I know about the fence already? I know what? I have 500 feet of fencing, so I can't just make it whatever I want. So I know that this plus this plus this has to equal what? 500, okay? So I know that 2x plus y is equal to 500, okay? What does this mean that y is equal to? How do I solve this for y? 500 minus 2x, okay? So that means that this side of the rectangle is x, this side is 500 minus 2x. What happens when you add x plus 500 minus 2x? What do you get? 500, which is what I expect. I've got 500 feet of fencing, okay? So this side is x, that's x. If I only have 500 feet of fencing, this has to be 500 minus 2x for this side. Does everyone see how we got that using the perimeter? Now, what's the objective? What do I want to do here? The biggest area that I can maximize the area. How do you find the area of a rectangle? Yeah, so the area is going to be the length times the width. Okay. What is the width of this triangle? So area is going to be, first of all, I guess I'll do length. The length is what? 500 minus 2x. And then the width is x. Does that look like a quadratic model? This will be where you say yes. So area is equal to 500x minus 2x squared. Now, that's a parabola, right? Where you say yes again. Yes. It's a parabola that opens in which direction? Down. It opens down. So if a parabola opens down, do you think it reaches a maximum? It reaches a maximum at a very special point called the vertex, okay? So I know that this parabola looks like this. It will reach a maximum at the vertex. So this problem boils down to find the what? Find the vertex. So the vertex is going to be x equal negative b over 2a. So that's going to be negative 500 over 2 times negative 2, which is 500 over 4, which is what? Well, negative 500 over negative 4. Okay. So the x is equal to what? 125. Now, is that my answer? What did they ask here? They asked what are the dimensions of this rectangular space here. What did I solve for? I solved for x. So I know that that's 125. I know that that is 125. How do I find y? Yeah. It's 500 minus what? Yeah, so 500 minus 2 times 125, that's equal to what? 250. Okay. So this rectangular area for the fence is 125 by 250. Now, how can I check and make sure does that answer make sense? How much fencing do I have? 500. So what would happen if I doubled this and added it to that? What would I get? 500. So that is the right answer there. So there's a little bit less work. I did not have to solve a quadratic equation here. All I had to do was find the vertex. So this is one of those where nowhere in this problem did I say find the vertex, but in course of solving it, you had to maximize something. The maximum occurs at the vertex, so you had to know to find the vertex here. Okay. So what was different was we had to use the perimeter. We had to write an equation in terms of one variable, and then we had to figure out where its maximum was by finding the vertex. Let's look at another example. Same problem. How would this problem change if that fence, instead of being 3 sides, was 4 sides? Okay. So let's see how that would change. This is x. This is x, right? This is y. And this is y. What do I know about the perimeter of this rectangle? 2x plus 2y equal what? 500. That means that 2y is equal to 500 minus 2x. So y is equal to what? So 500 minus 2x over 2. Okay. Or I could just write this, y is equal to 250 minus x. Okay. So in solving this for y, this is 250 minus x. So what is the area of this rectangle? What's the area? It's x times what? 250 minus x. And that is what? That's 250x minus x squared. Again, that's a parabola that opens in which direction? It opens down, so its maximum is its vertex. Okay, so the vertex is negative b over 2 times a. And what is that number? Is 125. Okay. So that tells me that this side is 125, 125. What's 250 minus 125? 125 and 125. So the maximum rectangle is really a what? A square, okay? So in this case, this would be a 125 by 125 would be the dimensions if my fencing was on all four sides, okay? And again, that uses up 500 feet of the fencing that I had. So again, it's reading through the problem, drawing a scenario, coming up with a quadratic equation. So you've got to get everything in terms of one variable. So I can't just say y is the width and x is the length and just have a problem in x and y. I've got to use some piece of information to get it as an equation of one variable. So in this case, we got it as equation in terms of x. Okay? End of the day, people are quiet. It's just easier or... Okay. You're tired. Okay? So I'm not saying it's easy, but I think we've been doing quadratics for a while. This should feel more comfortable by this point of the unit than it would have earlier. Let's look at another example. Pardon me, okay. So a rectangular patio is surrounded on three sides by a fence. This is one of those that it may not be extremely clear, but you know, you've got what you have here is you have a house, you know, or something like that, and then you have a patio. Okay. So you have a patio and you're building a fence. So you have a fence that goes on three sides. So you've got a fence that goes here, here, and here. So that's my fence. So similar to the scenario we saw a moment ago. So how do I define my variables? Any choice? What is easier to do is one of these variables I'm going to have to use, like whatever I define, you can see on this one, this is the same, right? It's easiest if you let that be x, okay? Because you've got x and x, okay? I could let this one be x, and then this will be an expression of x, okay? I find it easier if I've got one side that's repeated, let that be my variable, okay? Now, if this side is y, how do I find the perimeter? The perimeter is what, 2x plus y? What does the perimeter equal? 35. So that means that y is equal to what? 35 minus 2x. So this side is 35 minus 2x. So now I've got every side of that rectangle in terms of x. What else do I know? The area is what? 150. What's the area of a rectangle? Yeah, so it's just the length times the width. So the area is 150. So that tells me that x times 35 minus 2x equal 150. So this means that negative 2x squared plus 35x equal 150. I've got to solve this for x. So negative 2x squared plus 35x minus 150 equals 0. If I get it that far, how do you think I'm going to solve for x? This is where you should be reaching in your pocket for your TI Inspire. So menu. Menu, algebra, polynomial, complex roots. So it was what? Negative 2x squared plus 35 minus 150 plus 35x minus 150. That is equal to 0, but I know that's already implicit in this formula. Solve that for x. X is equal to, what was it, 15 halves and 10? Okay. So we got to take a look at this and see. So I'm getting two answers here. So I'm getting x equal 15 halves and 10. So I have to see if both of these numbers work. Let's start with 10. If x were equal to 10, this would be 10, 10, and then 35 minus 2 times 10 is what? 35 minus 20 is 15. So I'd have 10, 10, and 15. That would add to be what? 35. So that would work, okay? What about if x is equal to 15 halves? So I would have 15 halves, 15 halves. What's 35 minus 15 halves? Excuse me, 35 minus 2 times 15. What's 2 times 15 halves? 2 times 15 over 2. 15. 35 minus 15 is 20. So either one of these would work, okay? So both of these numbers, when I plug them in, give me the dimensions that make sense, okay? So it means my patio can be either, this is 10 and 10, and then it's what, 20 from here to here? Or no, if this was 10 and 10, 15. 10, 10, and 15, or 7.5, 7.5, 20, okay? So there are two different dimensions that makes this work. So your patio is either, so if it's 15 halves, you have 15 halves by, if I plug this in, 35 minus 15, that's 20. So it's 15 halves by 20, or it's 10 by 35, 10 by 15. Okay. Yeah, both of those work. When you get two answers, your choice is to like, okay, one of those, if one of those gave me negatives, or if one of those didn't work, you know, and gave me something that didn't make sense, you know, then I would be in the case of knowing which one to get out of. But in this case, both of those work for us. Pardon me? No, you could get one or two answers in this, so you're not guaranteed. Pardon me? Why would you only write one? You're going to get two answers. You've already done the work. You've got to check them. At this point, when you get to here, you don't know. You've got to check both of those to see if they make sense. You've got to do the work, okay? So you should be substituting it in, so you should tell me that one of these doesn't work or they both work. So in this case, there are two possibilities that will work for us. Now, let's change this up again. Instead of this fence being 3 sides, what if this fence were 4 sides? So same problem. I've got x, x, y, y. What's my equation that dictates the perimeter? 2x plus what? In this case, 2x plus 2y equal 35. So if I solve this for y, 2y is equal to 35 minus 2x. Y is equal to 35 minus 2x over 2. So now I want to solve this for the area. The area was what again? Area was 150. So I need to figure out area is equal to 150 square feet. So the area is x times 35 minus 2x over 2 equal 150. Now what is it about this equation you don't like? How can we get rid of the fraction? Not divide. What if we multiply both sides of this equation by 2? Okay. If I multiply both sides of this equation by 2, I'm going to get x 35 minus 2x equal 300. Okay, I would rather work with that equation. Okay, so this is 35x minus 2x squared equal 300, or minus 2x squared plus 35x minus 300 equals 0. And what do I do with that one? Yeah, I go back, and fortunately, I should be able to do it pretty quickly. Go back, recall this equation. Well, when I multiply on the left side by 2, that cancels, okay? It stays right there, 35x minus 2x squared, right there. Well, you've got factors. You've got 2 times x times 35 minus 2x. These are all factors, okay? So it's true, I'm multiplying everything up here by 2, but I'm also dividing by 2. So 2 over 2 is equal to 1, okay? It doesn't matter. These are all factors multiplied. It doesn't matter where I put this 2. I could put it here. I could put it here. It doesn't matter. These are all factors. This times this times this divided by this. Okay. The reason I chose to do that is because I wanted to get 2 over 2 to be 1. Okay. So we're down to this equation. We'll plug this guy in. And what do I see here? Did I do this right? Negative 2x squared plus 35 Now, what does that tell me? What did I get here? Let's just do it this way. What kind of numbers are those? Come on, come on, come on. Complex numbers. So what does that tell me? There's no real solution. So there's not a way to do this and get that 150. So I can't do all 4 sides with, what, 35 feet of fencing? Okay. There's no way to do all 4 sides with 35 feet of fencing and get 150 square feet. Okay. It is not possible. So in this case, there is no real solution. Now I could make 4 sides of a fence around there. I could make 4 sides of fence, but I can't make it 150 square feet. Okay, so that amount of fencing is not going to work to get 150 square feet. Now, if you wanted to figure out what the maximum, what if I figured out, if I wanted to figure out what's the maximum that I can get, what would I need to go find? The vertex. So I could find the vertex and figure out what the maximum would be, and it's probably going to be a number less than 150 in this case. Okay, so that was a trick one there. Let's take a look at another example here. A farmer has 1,500 feet of fence with which to fence a rectangular plot of land that borders a river. Okay, find the area, the largest area that can be fenced. So I've got a river, and I'm going to put a fence around the river. So automatically my fence has, or up to the river, my fence has how many sides? 3 sides. Easiest thing to do is, which of these sides is repeated? This one. So I'm going to let this be x. Okay, whichever side is repeated, I'm going to let that be my variable x. Just sets up much more simply. This one is y. What do I know about the amount of fencing? It's what? How much do I have? Am I not hearing it, or like am I just hard of hearing? Do I need to put these over my ears? What? 1500. Okay. So the equation is 2x plus y has to equal what? 1500. So what does y equal? Yeah, 1500 minus 2x. So this side right here is 1500 minus 2x. What am I trying? What is my objective with this problem? To do what? To maximize the area. So the area is going to be x times 1500 minus 2x. So the area is 1500x minus 2x squared. That's the equation of a what? Parabola that opens downward. So its maximum would be its vertex. So if I can find the vertex, I know what maximizes the area. So the vertex is going to be x equal negative b over 2a. So that's going to be negative 1500 over 2 times negative 2. So that's 1500 over 4, which is, what's that, 750 divided by 2, 350, 375? Did somebody do that with me, or? Okay. So it says x is equal to 375. What did they ask me? The largest area that can be fenced. So I know that x is 375. And then what is this other side? 1500 minus 2 times 375. So 1500 minus 2 times 375 is what? That's 750. So this area is 375 by 750. Okay, pretty straightforward. I feel like these are pretty simple, the ones where you just get the model and then go find the vertex, okay? Because there's not any ambiguity, you're going to get one answer. Yes, Aiden? Perhaps. I mean, does the science teacher count off? I mean, okay, doesn't care. Okay, we'll care in here. Okay, yeah, you guys should know that. I mean, this is, answering the word problem. This is about the bare minimum. I'm not making you write words, but at least you know that. So it's 375 feet by 750. You can strive for that. So let's look at the next one. I think this is the last one we have. 400 meters of fencing encloses a rectangular field having an area of 800 meters squared. Find the dimensions of the field. Okay, so I've got a field and we've got a fence that goes around it. Okay, so the area is 8,000 square meters. Now in this one, it doesn't matter if I do XX, XX, it doesn't matter. Okay, I've got the same number. So I'm just going to do this. That's X and that's X. Okay, and the other side is what? It's Y. Okay, but I need to come up with a relationship that is X and Y. So what do I know about the perimeter of the fence? It's 400. So 2X plus 2Y is equal to 400. So 2Y is equal to 400 minus 2X. Y is equal to 400 minus 2X over 2. Or Y is equal to 200 minus X when I divide everything by 2. So now I know that this side is 200 minus X, and this side is 200 minus X. Now, what do I do now to find the dimensions of the field? The vertex is finding the maximum, okay? The area is equal to what? What's the area equal to? 8,000. So I know that the area is 8,000. What's the formula for area of a rectangle? Length times width. So I know that x times 200 minus x has to equal what? 8,000. So 200x minus x squared equal 8,000. So that means that minus x squared plus 200x minus 8,000 equals 0. How do I solve that? That's with the calculator. So I'm going to go over here and say menu, algebra, polynomial, complex. So minus x squared plus, what was it, 200x minus 8,000? 200x minus 8,000, comma, x. What is that? So let's get an approximation here. So I see two different values here. I get roughly what? 55.27, 144.72. So let's write those down. 55.27. And what was it? 144.72. Okay. So in that case, my dimensions, I've got two different choices here. So I've got 55.27 times 200 minus that, or I could have 144.72 times 200 minus that. So I'm going to have two choices here. So it's going to be 55.27 by, what was it, 200 minus 55.27, or it's going to be 144.72 by 200 minus 144.72. What's 200 minus 55.72? It's what? 200 minus 55.72. Oh, you're right. What's 200 minus 55.27? 144. What is it? Point what? 73. Okay. So that's one choice of the dimension, 55.27 by 144.73. And then the other choice would be 144.72 by what? Come on, guys. What's 200 minus 144.72? 55.228. What do you see here? What? These are the same thing, okay? So even though it looks like I got two answers, these are really the same dimension, okay? So it's a square, or excuse me, it's not a square, but I get the same dimension either way. So here, I've got both of these solutions, but they get me to the same dimension, okay? But you need to plug both of these in to figure that out, that is the case, okay? And it should end up being the case when you've got four sides, it should work. The one where it didn't work for us is that one that had the three sides.